Well, hello and welcome to another episode of Leadership in the Age of Physical AI. I'm particularly excited about this one because we have a wonderful guest here and we're going to deep dive into the technical series. And who better than Prerna Dhareshwar? She's a machine learning engineer and she is going to talk us through some of the more interesting stacks in physical AI. But before that, Prerna, do you want to just tell the audience a little bit more about yourself?
Yeah, happy to introduce myself. Firstly, thank you for having me on here, Tito and Nathan. Super excited to chat about physical AI with you guys today. So I am on the product team here at Voxel 51. And most recently, I led a product that enables physical AI teams to work with their data. And working with that data specifically means being able to explore, visualize, curate, and query their data. And before this, I was a machine learning engineer building vision-based anomaly detection systems in manufacturing at a startup called Instrumental. And basically, both of these experiences taught me how critical data is in training successful AI models. And so I'm really excited to chat with you guys today about data and models and physical AI.
No, that's awesome. I mean, computer vision is not new, right? I mean, we've had computer vision for the last 20 years, even longer than that for military applications. But what's changed? Can you talk us through, you're talking about multimodal approach here. What's changed? Why are we where we are, if that makes sense?
Yeah, absolutely. I think physical AI is really having its moment. Especially over the last 2-ish years, you've seen the term take off. You've seen a lot more investment in this field as well. I mean, there's a new humanoid robotics company almost every day getting a lot of investment and insane valuations also. And it makes you think, what is it about physical AI that's making it have its moment right now? So taking a step back, it really goes back to what large language models taught us about how these AI systems can generalize about the world. So in 2022 or so, when ChatGPT was released, everyone was kind of mind blown at how well, from a language perspective, these models could tackle a lot of problems. But what was lacking was their application and their impact in the physical world, right? So they could chat with you on your phone or your laptop, but they didn't really have any physical impact in the real world. But what we realized around that time was that these same architectures that enable generalization in the language world could also enable models to operate in the physical world. So the same architectures work. So language is basically next token prediction, but physical models are next action prediction. So it's really interesting that the same architecture that enables these large language models to chat with you is the same kind of architecture that can help models work in the physical world. So think about humanoid robotics, humanoid robots coming into your house, cleaning up your house. That kind of thing is like actual impact in the real world, and the same type of architectures and algorithms can help power both these humanoid robots as well as large language models. So just realizing that the same type of architecture could work to generalize in the physical and real world was, I think, the impetus to for a lot of physical AI companies getting investment and capital and interest.
Well, no, that's awesome, and it's amazing to see how far LLMs have come ever since the transformer model was kind of productized around 2018, and it's amazing the work that the companies are doing. But we've got somebody here from the industry as well. We've got Nathan here, and he's actually implementing some of these solutions out in the wild. And I'm keen to hear from you,
Yeah,
Nathan.
so I'm I'm interested to hear
The
around
Bear
some of
Grylls, yeah.
combining, yeah, combining the opportunities within manufacturing, and especially around mining. Any improvements mean quite a big degree of return on investment or operational profit. And when you're dealing in small percentages, because you're dealing in hundreds and thousands of tons a time, and you're processing large quantities of ore, if you can maintain a more consistent return on that ore to give you the concentration you're looking for, then you make more money essentially. So where I really see the opportunity is really gaining a foothold in physical AI infrastructure in mining. And they got to be kind of ready for it. And I'm wondering how they could enable themselves to be ready for that transition, or maybe they're not even thinking about it yet. But how do we get them to start thinking about it and being enabled?
Yeah, that's really the $1 million question, right? How can you
Mm.
use physical AI in the industry that you're working in today. So I think some of it comes back to just understanding what the applications of physical AI, the successful applications of physical AI have been in different industries, and what out of that can we lift and put into the industry that we're talking about. So in manufacturing, we're definitely seeing physical AI having value and impact. Specifically, there are examples of robots being used for automation. And this is not a new concept, right? We've seen robotic arms that do various parts of the manufacturing process. But when you think about processes that are a lot more manual up till now, where there was operator involvement or human involvement, and you couldn't really automate it away with the robotic arm, possibly because you were dealing in more complex three-dimensional space, those kinds of things are also being automated today with humanoid robots. So there are examples in manufacturing, and specifically in like auto manufacturing. We've had conversations with people in the car manufacturing space, OEMs, who use humanoid robots to manufacture car parts and even assemble the car, which is a pretty interesting application for physical AI. So we are seeing that there is value, there is time that can be saved, there are quality issues that can be addressed, there's lesser mistakes, lesser parts wasted, less rework time. And since it is showing promise and it is showing value in that industry, and it is kind of similar to manufacturing in other industries, I think it is a good sign that physical AI can be applied in other manufacturing spaces as well. So just understanding what's happening in other industries, seeing how it's being adopted, and figuring out what pieces of that can be lifted and applied and generalized to other industries is a good starting point when people are thinking about, can physical AI be used in my industry?
I mean, heavy
That's a
industries
good point.
heavy industry has always been the last
Mm.
frontier. We had computers come in probably the last, and that's kind of when you know the technology is saturated around the world, and because it's one of the most complex processes to break into. But we had someone over from Goldman a couple of weeks ago, and a couple of episodes ago, rather, and we had an interesting question from him. So the overwhelming attitude within the investment community is that this physical AI is all about cars, self-driving cars, right? Can you talk to that?
Yeah.
Tell us where we're at. Why? I mean, is physical AI just self-driving cars? Because in the mines as well, that's all they talk about: self-driving haul trucks and self-driving utes, which is cool. But what's the value there?
Yeah, it is cool. And I think a
Yeah.
lot of that goes back to just the fact that self-driving has had such a big head start, right? I mean, Waymo's started like over 10 years ago. They started collecting data, they started having actual drivers drive around, collect data, and they've just had such a big head start and had so many years to get to this point where you now see self-driving cars out there, you see self-driving trucks, and not just Waymo's, right? There are a bunch of different companies doing this. So the fact that they've had such a big head start means that they're so far ahead that the types of problems they face and the type of success that they've seen is just a couple of steps ahead of all of the other people who are building in the physical AI space. So definitely autonomous driving is not the only industry where we see physical AI. Specifically, I think robotics is taking off quite a bit over the last 2-3 years. Like I mentioned, I think applications in manufacturing, applications in cleaning houses, and humanoid robots for various use cases is
I want two. I
picking
want
up.
two of them.
Yeah.
Yeah, I want two of them. The ones I clean my house. So
Yeah, for
definitely in the
sure.
queue for that.
Yeah, because I'm based out of San Francisco, I see a lot of ads for humanoid robots that will come to your house and clean your house for a flat fee. I'm very seriously considering signing up for one of those, but we'll see. Yeah, but
By the way, how much are they charging?
it's actually a flat fee for one of these. I think it was like a flat fee of $150, irrespective of the size of your house. So I was like, that sounds like a good deal,
It's
right?
pretty good.
But that's where the value is, right? Yeah.
Yeah. But then you pay them
I think
$150 and they leave you with a bunch of broken dishes. I don't know if I'm quite
You're
ready for that.
underselling physical AI now. We are underselling physical AI. Or here's the thing: they need better software.
Yeah. I mean, it's real risks, right? We believe in the potential, but acknowledge that there are real risks and issues still that they're working through. I think
Prerna,
that's
I'm glad you said that. Sorry to cut you off. I'm just glad you said that because we've got a lot of executives from the industry that we are in. They'll be listening to this and say, "It's the same thing. I don't want a damn robot coming into my into my mind side or my site and breaking stuff." So I'll let everyone else figure it out because we have a saying, right? It's not the early bird gets the worm. For us, it's the second mouse gets the cheese.
mm-hmm.
So
Yeah.
I'm waiting for the first, mouse to die off before I use it, right? So, talk to us. I mean, you are at the frontier of some of these technologies, and yeah, I mean, are we there? Do we have to be that scared?
Yeah. Great question. I think it is complicated, right? There is some amount of like risk appetite with new technology and with AI. I think we're at this point where it is proven out a little bit, and we're seeing that these models can generalize really well to unseen situations in the physical world. So it's at this point where it's no longer so risky to start implementing or start trying out solutions for your use cases. I think there has been sufficient experimentation already in the physical AI space in terms of models where you can see that there's success in some and specifically value in many industries. So I think it's no longer so risky to go try out something in the physical AI space. I do think it's a bit more proven out. I would have probably had a different opinion like a year ago or 2 years ago, but I'm seeing a lot more promise. Even in the vision-based conferences that I've attended this year, there's just a lot of talk and excitement around physical AI models. And I do think the value justifies the risk at this point. Yeah.
Absolutely. And Nathan, so what should
Mm.
we do to convince one of these managers to implement a physical AI solution?
So I think because everyone's using ChatGPT and everyone's having a little bit of fun and, but they don't know the extent to where you can take it. And that's probably the general consensus. So you kind of need to hold people's hands a little bit. And it's hard to get adoption in industry that's always been so, mechanically
Conservative.
dominated or,
Yeah.
not necessarily digitalized. It's analog. So you need to kind of convince them what the benefits are. And I think, how is physical AI different from conventional automation, machine vision, and predictive maintenance? It's how do you define that to these people? And I don't know the answer because there needs to be suitable outcomes as well. So, like your analysis, we need to go to those other industries and try and figure out what worked there.
Yeah,
That de-risks it somewhat.
And
definitely.
Prerna, he's talked about an interesting point about data. I mean, I'm dying to get there, right? Like we need to talk about how do we get data to train these models, right? Especially from
Mm-hmm.
so we break into mining, the job's done, right? That's the last frontier because mining involves self-driving cars, it involves manufacturing, it involves aerospace, it involves rail, you name it, it's all in one little site, like a little city, right? So and just before we get into data, I want you to talk to a little bit more about the work in software that you're doing, which was absolutely fascinating when I heard about it. And we're so glad you're here to talk to that software end, right? And I don't think people appreciate how much the software is the key differentiator for physical AI going forward. Everyone's like trying to build five-fingered robots and six-fingered robots and quadrupods and whatnot, right?
Mm-hmm.
No one's talking about the software side for physical AI.
Yeah, absolutely. So I think kind of bridging what both of you said, Nathan and Tito, the difference in physical AI systems versus previous automations is just that these models can generalize better. So you don't really need to train on every single use case and every single form of data. They're just able to kind of generalize from the information that they've taken or the information that they've been trained on. On new situations that they're put in, they're able to generalize better. Now, why this happens is because of the data, like you were mentioning, Tito. So data is really critical to how you train these systems. And a lot of training your models goes back to how good your data quality is. And needing to work with that data means that you need to have really good tools to work with that data. So what we at Voxel 51 did was build a platform that enables you to work with your data. And physical AI data is extremely complicated, right? There's a bunch of different sensors. All of them are not time synchronized. They're all recording information at their native frame rate and native frequency. And they're all, like I said, not synchronized. So they're coming in at different frequencies. And you have data over a large range of time also. So you need to be able to work with all of that data. You need to be able to label and curate all of that data and feed that data into your downstream models. And once they are trained on that data, they have to also be able to generalize to unseen situations. So all of this just requires having really good tooling that helps you work with data really well with a very strong focus of improving your downstream models. So that's kind of the work that I've been doing over the past like 6-ish months, really focusing on what kind of tooling should we build to enable people who are building physical AI models to get confidence in the data that's being fed into those models. Yeah.
No, but that
Yeah, that brings up an interesting point, doesn't it? Because why does combining the cameras, the different sensors, why does all that, there's a lot that can go into it. And I think your expertise is around the LiDAR, radar, audio, thermo imaging, and machine telemetry. So how does combining all that give us access to the capabilities of physical AI? And why is it better than just vision alone?
Yeah, absolutely. So multiple sensors just give you more information about the world. It's similar to how we as human beings operate in the world, right? So it's not just vision with which we perceive the world. We perceive the world with a lot of other senses as well. We use our hearing. We have two eyes, so we actually have depth perception. If we had a single eye, we wouldn't have as good a sense of depth. So we have depth perception, we have audio, we also interact with the world with our hands, with touch, with we understand what kind of surfaces we are interacting with. We understand what properties those objects have. Humans have the ability to lift something that's extremely delicate and know exactly how much pressure to apply to it so it's not broken. But at the same time, with more heavy objects, we know exactly how to lift it, given that it's an object that has properties which make it really heavy. So we have so many, as humans, we have so many different inputs that we take in. So similarly, for physical AI systems, if we provide just one sensor, which is a vision-based camera sensor, we're severely limiting how much information it can process and gather about the physical world it's operating in. So more sensors just give it more information about the world. I think there's this classic argument of, especially in the autonomous driving space, the classic argument of, is just vision sufficient or do we need vision and LiDAR? There's that Tesla camp that argues that vision alone is sufficient. But then there's all of these other autonomous driving vehicle companies that use LiDARs. And truly, I do believe that LiDARs add a lot of value. When you look at the kinds of edge cases that LiDARs help solve, you just realize that vision alone can't give you all of the information you need. I saw one example where there was a Waymo that was parked behind this truck, and there was a person crossing from behind the truck, and the Waymo's cameras obviously couldn't see through the truck that was blocking its cameras. So it couldn't see that there was a person there, but the LiDAR caught it. So that kind of thing, if these kinds of safety critical situations are what additional sensors help with. But beyond these like safety critical edge cases, there's also just more information that you get with more sensors. So being able to build systems which have sufficient information that they can perceive about the world is a really good way to start when you're thinking about building physical AI models.
I mean,
It's a
I
good way
think,
of putting it.
see, one of the things that's underrated about this is also, see, one of the issues we have both with AI, and next week we're actually going to have someone from governance talk to AI, and we have no trust in AI, and we have no trust in these, the world would call it like those damn self-driving cars. And even though they've reduced deaths and injuries by X percentage, there's still no trust. And I think having an education around the software that goes into them, I think will go a long way to build that trust, right? So I just have an interesting anecdote. Well, actually, an interesting story. My professor, when I was in school, he mentioned something really interesting, and I think you'll find this fascinating. He was actually involved in the Apache gunship program. and he was involved in testing it and getting it battle ready. Most people don't know, but Apaches were one of the first weapon system in the world to incorporate machine learning and machine vision systems. So what happened is that they could fly out into a battle space, and with the sensors and with the cameras, they could actually detect all the threats and then prioritize them. So the workload on the actual pilot was and the gunner was reduced by 70 or 80%, because you're not under decision fatigue to kind of go, oh, this is my highest threat. I need to coordinate all these actions. Now, something interesting from that point was the lens on that camera was made out of pure sapphire, and it had to be perfect. The manufacturing had to be perfect, because if you are a physics student, you understand this chromatic aberration. There's a lot of imperfections with a camera lens, and the software just wasn't good enough to manage it back in the 1980s. And so all of that had to be done at the physical layer before the software got a clean image. And we'll talk to noise and VLMs and all that in our next episode. But it's fascinating now that that's something that a multi-million-dollar weapon system could do back in 1980s. I could do that with a $10 sensor from Kmart. So are you seeing the same thing? Are you seeing this rapid sort of a rapid progression where software is catching up and we're not relying on hardware so much?
Yeah, absolutely. I think that's a really good way to put it. I think the focus has been shifted from what are the sensors we should use, how should we do sensor fusion, that kind of question, to now being these are the sensors that we have. How can we get our system to operate in the real world? And all of this, I think you foreshadowed a little bit, but all of this, I think, is enabled because of VLMs. So these models, because they are trained on the whole corpus of the internet, they're trained on both language as well as available vision, which is videos and images that are available on the internet. They have a really good understanding of the world, kind of. So they're able to generalize really well. They understand what text is associated with what visual inputs. And these systems are now being brought into physical AI. A lot of the focus is on, given this output from your sensors and given this text prompt as your goal task, how would you achieve the goal? And what set of actions would you take in the physical AI world to achieve that goal? So this means that to these systems, the sensors are fixed. The goal, which is the text prompt goal, is fixed. And what is in the system's control is the set of actions it can take. And we are realizing more and more that being able to teach a system to generalize and perform any type of goal using any sequence of actions is a lot more sustainable of a way to build a physical AI system than to focus in mainly on the sensor types or the hardware itself. So we're definitely seeing a shift from people focusing on the hardware to now focusing on the software that powers these systems.
I still don't think there's enough discussion or education on the software side. Are you seeing the same thing, Nathan, about software and physical AI is all? People think it's all about the hardware.
Yeah, so this is a good point to bring up, and I'll get some input from you, Prerna, and on this, because there's something I would call low-hanging fruit in the space in manufacturing mining, where we are able to do something called digital twin technology, and it's just simulating controlled environments, process environments, especially around process where you're doing separation and it's not discrete automation. So that's and most of the sensors are already there and basically installed. And then we depending on where you're coming from, there's other names for it like advanced process control technology. And basically it comes from LLM and deep neural networks. And this stuff's been around since the 70s. So a lot of people don't realize that it's all software related and how you augment that data into more controllable parameters such as PID loops, which are more arcane to running the plant at optimal. So, but where I see the software needing to be developed and where sensor technology could be implemented around more capable sensor technology is going to physical AI, as you explained before, why you need all these, not just vision alone. The baby, if we think of a baby, feels, touches, seeks, understands. It's learning as it goes. Now, the way I see physical AI is it needs to learn as it goes. It needs to be self-learning, self-healing, self-governing. And I wonder how to get this digital twin technology to a point, instead of needing large caches of LLM data, because you can't just install one of these things until you have a lot of data for it to learn from. And it may take 2 years down the track before the mine is confident that it's got enough data that it can install one of these processes that could improve throughput. And so where we could make a really big benefit is enabling this technology right from the get-go, say on a greenfield site, where it self-learns, it self-governs, and then you wouldn't have to wait 2 years to get those benefits. Again, it's reduction in engineering and integration as well, so you don't need as many engineers to go through it. So how do we get there? What do we do to enable that? How do we get to self-learn?
Yeah, great question. I mean, I think one of the first steps is just ensuring that even if you're not ready to deploy models, at least you're collecting data in the right way. I don't think it's ever too early to start collecting data from whatever industry you're in and making sure it's collected in such a way that it's clean, usable, structured in the right way, and just stored so that in the future, when you're ready to start implementing AI solutions for your use case, you have the data necessary. So I think the first step is to just look at your data processes. Are there places where you can collect data and store data relevant to your use case that might help you adopt AI technology that can work on those use cases in the future? I think the idea of self-learning is something that is kind of a more general idea that's not industry specific, but is just a model related capability that is something people are building towards in the frontier labs. So I think given new information, how do you quickly understand that new information and now are able to apply that new information without a whole huge process of training on hundreds of GPUs? That's the goal, right? And I do think we are trending towards that. I think when we say we'll have AGI, artificial general intelligence, I think different people have different definitions of that. But I do think being able to learn new concepts really quickly is a very large part of AGI. And you're absolutely right that that's how humans do it, right? We are able to learn given very few examples of something. When you think about classical vision systems, if you just showed it one ostrich and said, this is an ostrich, and then showed it another ostrich, it would not be able to tell you that that is an ostrich. But humans can, right? You show them like one or two examples of an animal, you show them that same animal in a different like angle or a different context, they can very easily apply the information that they learned. So being able to learn with very few examples, it's actually called meta learning in deep learning. So that is something that's, I think, very critical to AGI. And I do think that all of these LLMs and VLMs are trending towards that. So right now they have this notion of a context, right? They condition all of their answers on information that you provide them. So they do some notion of self-learning to a small extent. I do definitely see that we'll continue to improve in that space. And once these models themselves are able to self-learn, I think self-learning in any industry will become easy and will come naturally from.
I mean, this is an amazing time. We're almost out of time here. And Prerna, thank you so much. It's been so informative. But hold on, we need you back. We need to deep dive into these models, these VLMs, understand noise and how to filter out noise, which is what all the engineers listening to this will be asking. And you can't wait to get into it. Nathan, Prerna, thank you so much, and hope to see you on the next episode.
Thank you so much. It's been a pleasure. Excited to chat with you again.
Yeah, great to meet you. Thank
Yeah.
you.